Today we will be continuing with the lesson, well, the unit of quadratic functions. All right, we did 2 lessons before break. I'm hoping you did not forget those. How to find axis of symmetry, vertex, and graph quadratic functions by hand. Even if you weren't here, or even if you forgot it, you are still held accountable for those lessons. They're thankfully recorded, and you can just watch them in Schoology if that applies to you. Otherwise, we are moving on. Today, we're doing the vertex form of quadratic functions, learning how to identify axis of symmetry, vertex, and how to graph those. Tomorrow, we'll continue the lesson, but it'll be more like how the graph moves up, down, left, right, and all that good stuff. So today I will be updating grades, sending out a failing email if you are close to failing or have an F. So just look out for those. Mostly, like, the distribution is pretty good in my class, in all my classes. So I'll have like some stats for you from the last unit test, and I'll show you them just like I did for the unit before that. All right, but I'm recording today's lesson now. I'll link it in here, just like always. If you want to get ahead, I usually use the same materials from last year. So the videos from last year are also linked in there, and some other like shorter, helpful videos that I did not make. The practice you will receive tomorrow, and it'll just be evens or odds. So hopefully you have time to work on it tomorrow. This lesson may or may not move into Wednesday. So depending on when we finish the lesson and the practice, we'll do the exit ticket maybe tomorrow, maybe Wednesday, just depends. So be aware of that. There's exit tickets for every lesson. They're supposed to be something that you just use your notes on, not something that you need to cheat on. So because there's been so many people trying to cheat, I've been putting it in the lockdown browser, which I hate because it's like glitchy and stuff, but it is what it is. All right, make sure you bring your Chromebooks every day for your calculator and your exit tickets. So any questions on anything? All right, so then starting with the notes, the vertex form of a quadratic equation is y equals a parentheses x minus h close parentheses squared plus k. All right, so vertex form of quadratic equations. Y equals a parentheses x minus h close parentheses squared plus k. All right, and compare that to standard form, which we talked about before break. What's the standard form of quadratic equations? Anyone remember? Y equals a x squared plus bx plus c. It's been like a week, but make sure we retain that information for our topic test. All right, so with standard form, we had to identify axis of symmetry and vertex by using formulas. So I'm just going to show you that, and then we'll come back to this. All right, so remember, for the axis of symmetry, you have to plug it into this equation. To find the vertex, we have to plug in the x into the given equation and find y. So kind of a lot of work when it's in standard form. But when it's in vertex form, the hk will be my vertex. and x equals h will be my axis of symmetry. All right, the only tricky thing, I guess, is just figuring out the signs, but you can just look at the formula and automatically pick out the vertex and automatically pick out your axis of symmetry. So let's practice that in 1 and 2. All right, so axis of symmetry always needs to be in the format x equals, and when it's in vertex form, it's going to be whatever number is in the h position. So h is in parentheses with the x. It's being added or subtracted from the x. But in the vertex formula, it's minus h. So that means that it's going to be the opposite sign of whatever it shows you in the equation. So what number is in the h position? 4. But if I plug in just a positive 4, then it should look like x minus 4, shouldn't it? So what do I have to plug in to make that 4 become positive? Negative 4, good. All right, because x minus a negative 4, the double negative becomes positive, so that's what happened. All right, so if you want to just remember that all the h's will be like the opposite sign of whatever's in the equation, then go ahead. The k, though, will be whatever sign it is in the equation. So the k is easy. H is opposite. So for my vertex, the x should be negative 4, because that was h. And the k, what number is in the k position? Negative 2 is correct. So for the k, it matches the sign that's in the equation. For the h, it's the opposite sign. So questions on that process? All right, you can also use Desmos to verify. All right, but let's look at 2 together, and then I'll have you try 3 and 4. So axis of symmetry. X equals whatever number is in the h position. What number is in the h position? 3. Is it going to be positive or negative? Good. So my axis of symmetry is x equals a positive 3. My vertex, well, we know that x will be 3. The y of my vertex, or the k, what number is in the k position? 0. There's nothing being added or subtracted over here. So it's like doing plus 0. So questions on that? All right, I'll have you try 3 and 4. 4 is a little more challenging, but I'll have you try it anyway. So just do it in pencil. Give you about a minute. All right, so number 3, what did you say is your axis of symmetry? X equals, it should be positive. So your h will always be opposite sign of whatever's in the equation. So if it looks negative in the equation, it'll actually be positive. All right, so easy mistake to make, just fix it, not a big deal. Should be x equals positive 5. What about the vertex? 5, negative 4 is correct. So the k is easy, it matches the equation, positive or negative. The h is just always opposite. I don't have a little trick to remember that yet. If you think of one, great. But h is just always the opposite. All right, now axis of symmetry for number 4. What do you guys get? X equals. This one was the more challenging one. Is there a number in the parentheses with the x? So then my axis of symmetry is x equals 0. All right, so if you got that your first try, great. Some people in my last class thought it might be the -2. Well, no, that's A in vertex form. And then it's not the 3 because that's our K. So then our vertex is 0, 3. All right, questions on number 4. All right, and if you didn't understand axis of symmetry or vertex from those examples, well, we have plenty more to do down here. So hopefully you'll get it eventually. All right, but you see that the given equations in vertex form in number 5, so we're gonna graph them. Graphing in vertex form is really similar to graphing in standard form. First, you're gonna want to find the axis of symmetry. All right, so if you're a step-by-step person, I would write down these in the margin too. But step 1, find the axis of symmetry. So it's always x equals, what number is in the h position here? And since it's a +2 in the equation and the axis of symmetry, it should be good. All right, so that's step 1. Step 2, we find the vertex. So remember, vertex is your xy, but when it's in vertex form, it's hk. So, you know, h is -2. What's the k in this? 7, and that sign will just match whatever it is in here for the k. So questions about that? All right, now think back to the steps we did for standard form. After we find the vertex, what do we do with it? Put the vertex in the middle row of the table. So just like before break, just like with standard form. This will go in the middle row of the table. And the x's will be based off of your vertex, right? Because vertex is your middle of your graph. You're going to want points to the left and to the right of it. So left and right, that's your x's. What are some numbers before -2 on a number line? -3 and -4. Good. What are some numbers after? -1 and 0. Will it always be -4 to 0 on your tables? No, it just depends on your vertex. So use your vertex to make your table. How do you find the y's on your tables? You use your calculator. So I would get it out now because you are going to do a U try, so you might as well get it out. Whichever one you can use. When Sophia comes up. So step 3 was put vertex in middle of table. Step 4 is complete table with calculator. Or Desmos is the one that I'm wanting you to practice with because that's the one you'll use in April on the Aspire test. All right, but anytime you plug stuff in, it's a good idea to use parentheses. And for your scratch work, I would at least like to see on your paper you plugging in at least one of the x's. That way you know how it should look in your calculator. So then we get negative parentheses and then another parentheses, because anytime you plug stuff in, that's what you should use. All right, and that's how it should look in your calculator. I know the parentheses this time won't really make much of a difference in the Vertex form, but still it's good practice. Just anytime you plug stuff in, use parentheses. All right, once you get one of the calculations, you can just copy and paste and change the x. So now I plugged in -3. Now I'm plugging in -1. And so on. So questions at all? All right, and then you fill in the table using these values. So 3, 6, skipping the vertex because we already did it, 6 and 3. All right, once you've made your table, transfer that onto your coordinate plane. So remember that the positive x's go to the right, negative ones go to the left, positive y's go up, negative y's go down. So transfer that onto your table. Try to do it without looking at mine. But once you're done, you can look at mine. All right, and then that's what your points should look like before you connect them. To your nice U-shaped parabola. All right, so 2 more things we need to do is domain and range, which I'm hoping you guys have the hang of by now because we've been doing it all year. What did we say the domain will be for parabolas always? All real numbers. What about the range? Is it going to be all real numbers? No. The range does, so the y's, the graph doesn't go infinitely up and down, right? So we're going to have an inequality. We use the letter y because it's the range. What y value do we use? We're going to use 7. So just kind of look at where the graph stops. It stops at y equals 7. Or just use the y value of your vertex. Now, would you say that these y values are greater or less than 7? And then does it touch 7? So less than or equal to. And you can also just memorize that negative parabolas will always be less than or equal to. So questions on 5? All right, I'm going to give you number 6 to try, but let's just make sure we identify our H and our K correctly. So what will be our H for number 6? A positive 1 is correct. What will be the K? Zero is correct. So K is always added or subtracted. 3 would be multiplied, right? So 3 is actually our A, which we're not using yet. So H and K is identified. Follow the rest of the steps for number 6. So here's number 6, except there is one small mistake that they made in the graph. Anyone know what it is? What point is incorrect on this picture? The 1, 0. 1, 0 would actually be here. All right, but other than that, that's the only mistake they made. All right, they put 0, 3 in the right spot and 2, 3 in the right spot. We couldn't really graph -1, 12 or 3, 12 because the x's don't go that high, but just draw it with your arrows. All right, you know it goes on infinitely. So questions on, well, actually, let's go through it. All right, axis of symmetry is x equals h, and we said that h equals a +1. So x equals a +1. The vertex, we said that k is 0, so put it together, 1, 0, h, k. All right, from there, that's how you make your table. So vertex always goes in your middle row of your table. You'll want some x values before 1, like -1 and 0, and some numbers after 1, like 2 and 3. How do you find your y's? You find your y's by plugging in your x's. All right, the x's you get to pick based off your vertex, and then find your y's by plugging in your x's. I would at least like to see you on your scratch work show at least one of the points that you plugged in. All right, because the rest you can just like copy and paste in Desmos and change the x. But I just want you to practice writing down that you find the y's by plugging in the x's. Good? And hopefully you know how to graph on a coordinate plane by now. Domain is always all real numbers. That's another way to write it. And then range, you'll always have at least one boundary. So look at where the graph stops. All right, it stops at y equals 0. And these y values are greater or less than 0. Greater. All right, and you can also just memorize that positive parabolas are always y greater than or equal to. All right, good. Ready to move on a little bit? All right, so then some vocab, and then we may or may not have time for one example. We'll see. All right, but tomorrow we're gonna do a lot of examples on transformations from the parent function. So the parent function is going to be your most simplistic equation. So there's parent functions of all sorts of things. For quadratic equations, it's y equals x squared. Talked about that before. We've graphed it before. On your examples, like 7 through 10, you have your parent function already graphed. So that's nice. So that's what you're going to compare all the other equations to, is your parent function. So you can fill this in. This is known as the parent function. And then any other quadratic equation is just a transformation of the parent function. So transformations are a change to the size or position of a figure. All right, so some nice vocab there for you. A transformation is a change to the size or position of a figure. All right, so we're going to graph each function. The parent function is already on our graphs. So this right here is our y equals x squared, already drawn. And we're going to graph this. So in order to graph stuff, what do we find first? Good. You find the H for your axis of symmetry. So for this one, my axis of symmetry, x equals what? 2. -2 is correct. So that's going to be the x of my vertex as well. That makes sense? Always opposite sign for the H. What will be the y of my vertex? 0. You could do that 2 ways. You could plug in -2, just like we did before, or you can just look at it. There's no k, plus 0. All right, then do the rest with your calculator. What numbers come before -2 on the number line? And what numbers come after? Good, and then the y's, use your calculator. Maybe off to the side, write what it would look like when you plug in the first x value. So use your parentheses. And then from there, you just use Desmos, you can copy and paste it. Finish the table and graphing it. So that's probably as far as we'll get today. We'll talk about the transformation tomorrow. And I'll also do it on the board if you're lagging behind. And your y values should be 4, 1. We already have the vertex 1 and 4. All right, we'll finish the rest tomorrow.